Hello, everyone, from wherever you may be. I know there are a few people from the US. Welcome to the GSE UK Virtual Conference 2020. This is session 1BF on the agenda. Some of you may know me already, but for those who don't, I'm Dave Austin, and I'm a senior technical consultant with BMC Mainframe Services, primarily working on ZVM and Linux, but I do other things. Any questions, please, can you put into the chat window? I'll monitor that and interrupt the presenter, Rick Barlow, with any questions that you put there. I'll now hand over to your presenter, Rick Barlow of Velocity Software, who will take you through bare metal to Z15 cloud in 2 days. Over to you, Rick.
Great, thanks, Dave. Once again, welcome to everybody who's joined this afternoon. I know it's the end of your conference day and conference week, so I'm happy that some of you have decided to come and hear what I have to say. I have a long history in the mainframe world. I've worked with about 30 generations of machines, starting back with a 370. So I've enjoyed doing Z for my entire career. And so I'm going to talk a bit about the machine. I'll talk, well, quite a bit about the machine, how we did our setup and for this migration. The focus is really on the experience of this bare metal to cloud proof of concept that we did. But in order to talk about that, I'll have to talk some about how we got there and what we had to do in order to make that happen. Since our overall project also included migrating from a prior data center and an older machine onto the new Z15, all of our production workload, I'll talk about that some too. You know, I hear people all the time say that mainframes are too hard and they're too complicated. I'll plan to show you here in this presentation how we started from nothing but a running machine and got all the way to building a private cloud and provisioning virtual servers in just 2 days. So the topics we'll cover, I'll talk a lot about the planning because the planning is key to make this happen. In the implementation, I mentioned there are 2 phases, the bare metal to cloud proof of concept, and then I'll talk a bit about how we migrated our existing production workload from the old site to the new site, and a little bit about the results. So planning's critical, and we all know that that's critical no matter what the project is. In this case, there are a number of things you have to do. Since we were going to a brand new site, there are a few things that you might not have to do if you're staying in an existing site. So we had to find a physical site. We had to look at all of the facilities and utilities that you would need there. What we were going to do in terms of networking and the amount of floor space we needed and the redundancy in the data center, all of those factors. We figured out ahead of time what hardware we were going to get. We were fortunate to be members of the Z15 single frame ESP, and we put in a DS8000, a new 8910 all solid state. In our case, we needed a few routers in order to connect to the outside world, of course, and some switches, and that switches in terms of network switches, that is. And we have just a small number of support servers. Part of that planning also includes determining how many what types of IO cards and how many of them you need. So that is mostly determined by what peripherals you're going to plug in. You got to have some cables, even like in our case where we have a very simple configuration. You better plug the IO in or nothing happens. Of course, we had to arrange for the purchase and the shipping of the hardware. And then there is some work to be done in terms of defining LPARs on the machine. So I'll talk a little bit more about a lot of those topics. And then, of course, in the software space, you need to have some sort of a cabling plan, and that would include, knowing what peripherals are going to plug into what parts of the machine. The hardware planning tools do a really good job of helping to make sure that you don't do something silly like plug all your connections to a single DASD frame into the same card. The IBM chiphead mapping tool, which is provided on the Resource Link website, is very good for that. First time around, you have to create some sort of an IO definition. So we had to create an IOCP for this new machine. Some other things that are pretty important, especially when you're looking at a brand new machine, is you look at the driver exception letter. That will give you some clues about software you might need to install in order to support it, and any things that might be unique about this new machine that potentially are different from older generations. So you definitely want to look at that letter. And then most of you who are familiar with installing mainframe operating systems know that IBM provides these preventative service planning buckets. In this case, the device type of the z15 TO2 is an 8562. And since we were on both ZVM and ZOS on the machine, we had to go look at the subsets for both to make sure we had the required maintenance on. You'd have to install that maintenance. In our case, we had the majority of the support already included because the support for the single frame Z15 is almost identical to that for the multi-frame that came out a year ago. So there wasn't a lot of new code that we had to install. When we upgraded to ZVM 7.1 about mid 2019, I picked up most of that maintenance, but you'll always want to look and make sure that you have the most current. In terms of VM, there's a few specific things you have to do. The system config file may have the serial number and model type of your machine in it. If you don't change that, things may not initialize well. So look at that. System net ID, which helps for inter-system communication, is another one that's key. And vSwitch configuration. So if your configuration is identical to your previous machine, you probably don't have to do anything. But this being a brand new machine with new hardware, new IO device numbers, I had to do a little bit of work to make sure that those virtual switch definitions were correct.
I think that the system, sorry, Rick, I think the system config also might have some implications for the LPAR names as well.
It could, not always. The LPAR names are more frequently up in the LPAR definitions. That's what I'm trying to think of. System config may have some.
They tend to for the SSI environments anyway.
Yes, that's true for SSIs, and I'll talk a little more about that. But yes, so you could have some LPAR information there in terms of how your systems are connected, what resources are available to different systems. But I was thinking of defining the LPARs is another place, but actually using those definitions to help configure the runtime configuration of your systems. You're right. There's a number of things in system config. I don't go into a lot of detail in this presentation about that because this was more about the proof of concept and the migration. So in this case, every project has potential obstacles. Lots of things get in the way. I've done a lot of migrations over the years, and any number of things can happen. I worked for an insurance company for many years, and when hurricane season comes around, you don't do anything to your systems. Well, this case, we didn't have a hurricane, but we had a coronavirus. So all of this started up just before people started getting locked down in their countries about mid-March. So most of this migration occurred while we were in lockdown or we were in limited movement around the country. So that was kind of an interesting twist on the whole business. We had just signed up for the ESP when the quarantine began. So that was quite an experience. I mentioned this was all in a brand new data center. So, during this lockdown period, I had to venture out some. Well, I and the others on our team had to venture out and go to the new site. We had to physically, establish that site, physically install the hardware, and all of this was on the opposite nearly the opposite side of the country from where our production data center was. We had some interesting problems with our network provider. We chose, one of the larger global network providers in the world, but they had actually a physical hardware problem that gave us fits for several days, well, close to a week. So that was a challenge. In this case, because we were migrating, we were doing the proof of concept first and then migrating, we had to maintain connectivity in both places. So that was another experience. Often you'll find that people will set up a site-to-site network communication. We just used the existing communications in the earlier data center and brand new communications in the new data center. And we didn't set up any site-to-site communication. So everything we did went out over the internet and back into the other site. So that was sort of interesting. And this was leading edge. It was, as I mentioned, the z15 early ship. And sometimes things happen in that case. In our case, we actually discovered a small hardware situation, and I'll talk about that a little bit more in a few minutes. So what did we have to do? I mentioned we had an empty site. The first thing we did was just put in a rack. So you can see in the picture on the top right that there's an empty rack and an empty shelf. Those would eventually house part of the hardware, including a couple of standalone servers we have. That took only a few hours over several days to put that in place. When the Z15 arrived, it took us just about 4 hours to take it off a truck, unpack it, roll it from the loading dock into this cage, and stand it up and turn the power on. That was pretty impressive. The one thing I wish I had had a chance to do was to grab a picture of the crate. For those of you, I have a lot of various interests, but the whole idea of packaging fascinates me. There's a whole engineering science to packaging things in cardboard boxes for shipping them. Of course, we all get a lot of things now shipped from Amazon and other online providers. The Z15 was really interesting because it comes in a wooden crate, and the door is the ramp, and it's raised up off the ground. It's just a interesting piece of engineering. I didn't take any pictures of that, which really makes me a little sad. Who knows if I'll ever get to see another one unload like that. But basically, you flip the front down and it rolls out on its, you let it roll out. It doesn't roll on its own. It's not that smart. But you roll it out on the door and onto the bare concrete floor, and that's how it gets out of its crate. I kind of wondered how we were going to lift this multi-thousand-pound monster out of there, but it did most of the work for you. So that was kind of interesting. I mentioned we had a small problem. In this case, we found that the bottom line was a bolt wasn't tightened before it left the plant, and which allowed some vibration and caused a problem with the machine. And it wouldn't actually, while it powered on, it would not fully power up, which is, the whole checkout procedure that the machine does on its own. That took the hardware people, a little bit of time to discover the root cause of that. But that, as I mentioned, it's an ESP. That's one of the reasons there are ESPs. Customers like us discover those things, and the engineering plants fix it, and it doesn't happen to anyone else. So that's always interesting. ESPs are really fun from that perspective. You get to see inside. There's very few mainframe people who ever get to be that close to your machine and actually have hands-on doing the work. That's really an important part, I think, of getting the best understanding of your mainframe hardware. And so, just to prove I did it, I took a picture of me next to the Z15, just for the fun of it. So that was one day. I don't remember if it was the next day or 2 days later, but then we got the DS8000 and we had to unpack it. And you'll see several pictures of that on the chart. The packing of the pallets was another one of those interesting engineered packaging feats. If you look at the big pallet in the first picture there, you see it's very square. They packed it on the pallet and then they shrink wrapped the whole thing. Well, as we unpacked it, we found several of the boxes like the one at the bottom, which is an intentionally empty box. All it does is fill out the square pallet so that it's easier to ship. I thought that was quite interesting. And then on the right in that picture, you'll see the fully assembled DS8910. It took most of a day to unpackage all of the cardboard boxes. You'll see one of the components there. That's one of the PDUs sitting on the cart in the foreground of the first picture. All of that stuff had to be loaded section by section into that empty rack that was in our data center. And the picture on the right then is the whole DS8910 fully assembled and ready to run. It was fully powered up and checked out by that point. So I mentioned that a lot of people talk about how complicated IBM Z is. I would beg to argue that point. I've had hands on a whole lot of Z installations, and there are a lot less moving parts to our configuration than most others. The pictures on this chart show you the entire contents of our data center. Well, I guess that's not quite true. There are now 2 servers sitting on that wire rack as well. But in general, that's our entire data center minus 2 servers. It's kind of sad that it looks that empty. Keep in mind, we have one of the smaller Z15 configurations. We only have 1 processor drawer in it with only 2 of the possible single chip modules. Could have up to 4, and we could have up to 2 drawers, but we didn't need that much capacity. A single drawer Z15 can have up to 31 customer configured cores in it. If we had the 2 drawer machine, you can have up to 65 and up to 8 terabytes of memory in that single frame. That's a pretty impressive feat. And then if you look at the amount of connectivity between the mainframe itself and the storage subsystem, technically you could run that whole thing with a single cable between those 2 environments for a storage. We have 4. We have 2 for DASD and 2 for fiber channel. And then if you're going to talk to the outside world, you're probably going to have some sort of connectivity to a network. So we have another several IO cards in order to produce the network connectivity to the outside world. So all totaled, we have 8 cables plugged into our Z15. Now, if you compare that to what you would do if you had a rack full of servers that had that much capacity, or actually probably several racks, at least a couple, it'd be 2 to 4 blade centers most likely to have an equivalent amount of capacity that you could have in that Z15. And if you know anything about distributed servers, you know that every one of them needs multiple network connections and multiple network connections to the tune probably of close to that 8 that we have for our entire Z15. So talk about the difference in complexity. I would say this is a significantly less complicated environment than some of the servers. I should have taken a picture of one of the cages around ours just to show you the, row after row after row of racks full of distributed servers, but that probably wouldn't be a legitimate thing for me to do. So, and the other factors, if you talk about space and power and cooling, that's 2 19-inch racks. The Z is slightly deeper than a standard rack. I think it's on its own, I think it's only about 2 inches deeper, but the doors make it about 6 or 8 inches deeper. But it fits in the same data center space now as any other server rack. If you look at power and cooling, there is no question that the Z is more effective. In fact, if you walk behind this rack, since they both exhaust out the back, the DS8000 produces about twice as much heat as the Z15. it's pretty amazing. And if you want to see those statistics, you can actually go to display on the HMC, and it will tell you how much power you're consuming and what the ambient temperatures are and what the exhaust temperatures are. So you can see all that in real time on your machine. So I mentioned the migration was done in 2 phases. The first was our bare metal to cloud proof of concept, and I'm going to talk a lot more about that. We built a 4-member ZVM single system image from scratch. We installed the Velocity software suites, and then we installed a single Linux master that we could use for cloning. And then we did a cloning demonstration, and that was all in less than 48 hours. And I have a timeline here in a couple slides. And then, of course, we had to get our workload out of the existing data center. That environment had 5 more ZVM LPARs, 3 single systems, and 1 2-member single system image that we migrated. So I'll talk a little bit more about how we did all that. And on that system are a number of websites. Our corporate website, several customer things, including the VM workshop, are all served off of those systems. And in order to do that migration, we did our best to do all of that work overnight or over a weekend to produce no customer impact. And in fact, those people around us who use our resources, we didn't have any feedback that we'd caused any impact. And we have a number of ZOS and ZVSE guests. I did not do that migration personally. I facilitated all the disk migration. But you know, if you had questions on that, I can probably find out more details in that. But that isn't the focus here. I just wanted to let you know that we did have those guests running that had to be migrated. So here's an overview of the summary of the installation. I mentioned it was a 4-member ZVM single system image. It took just about 5 hours to load that. Now, in this case, we loaded it from a USB thumb drive. That was my first experience putting the ZVM distribution onto a thumb drive, plugging it into the HMC, and loading VM from it onto that DS8900. It was that was interesting. Some of the components are a little more difficult. RACF is probably our biggest challenge. You don't install RACF very often, and it isn't the most straightforward installation of anything IBM's ever produced. There's you have to use a number of different documents and make sure you do the steps in the right order. I think we actually made our life worse by not being fully prepared, having all the documentation in front of us. And I think we did one step out of order, which made our life more complicated. But all in all, it didn't impact our installation very much. The ZVM service, when you install from scratch a ZVM system, you get an initial RSU. In our case, though, since ZVM 7.1 was more than a year old, there were a whole bunch of there was an additional RSU and a bunch of core maintenance that needed to be installed. So that took a little bit more time in order to bring all the maintenance up to current on this bare metal VM installation. The Velocity suite is trivial. In order to install all of our components that we wanted, the initial ZVPS suite, which provides all the performance monitoring and management, and then ZPro, the provisioning tool and automation tool that we use to clone servers and manage the servers. All of that we did in about 4.5 hours, and it really wasn't in parallel. I suppose if we put more people to work at it, we probably could have run some of that even in parallel, but we were doing our regular day-to-day jobs as well. So some of us were, a couple of us were, I was dedicated to this. One of my cohorts was mostly dedicated, and then we had help from a couple other people. The Linux master image, that's just like loading Linux anywhere else. It took about 2 hours to do that. So this is a timeline. It's more of an eye chart, I guess. If you don't have a very big monitor, you might have trouble reading it. I produced this in order to just show you the extended timeline. So what you'll see there is actually parts of 3 days. We say we did it in 2 days, but if you count the number of hours, it's less than 18 hours that we took to install this entire system. And you'll see that the IOCP was trivial. The LPAR definitions took under an hour. Once again, it was all planned. I'd written all of it down to know what we were going to create, but under an hour, that's just the time it takes to do the work on the HMC. You know, installing the first VM system, it takes about 20 minutes, and VM loads all the other members themselves. So all of that, well, it's all on this timeline. I won't read it to you. You can take the time to do that when you want. You'll see the beginning of the second day. That's where we spent about our 3 hours on RACF trying to figure out what I did wrong the first time around to get it fixed. That worked out pretty well. In the afternoon of that day, there's a couple hours getting the rest of the ZVPS components installed. And then the last day just has the Linux master installation. If you look at that, clearly the Linux master could have been done in parallel to some of that other work on the second day once the systems are up and running. So we didn't push as hard as we might have to do it. Certainly if we did this again, we could cut some time out of the the RACF part of it, and you know, parallelism, we could have probably got it all done and easily within the 2 calendar days. So this chart is an overview of the installation of the Velocity software in order to provide the cloud management. All of these, except the last reference to the Performance Manager software, were completed in under 2 hours. So the majority of it was much shorter. So you have to allocate some resources. The VPS suite, Velocity Performance Suite, has its own shared file system pool. For those who are VM users, they'll understand what that is. If you're not a VM expert, shared file system is just a way of creating a pool of space that multiple user IDs can share at the same time. So thus the shared file system. And you have to define the user IDs. We have, oh, I probably should have counted. I think there's 10 user IDs in the suite. Download the software. That's provided by that web server that was on our old data center. So we download the software, install the installer, install the web server, install zPro, which is the cloud management piece of the puzzle. And then you load the Linux Gold image, which is the last step I showed on my Gantt chart the previous page, and install all of the rest of the performance management tools. If you're going to run a cloud of Linux images and or CMS and or ZVSE or ZOS, you want to know what those systems are doing. And our ZVPS suite is at the top of the list of good tools in order to monitor all that at minimal overhead. And I'm not going to talk about the whole performance suite in this presentation. That wasn't the objective. But if you would like to know more about that, you can use our website, or any of us would love to talk to you about it. So, and then toward the end of this POC, then we wanted to demonstrate the cloud capability. So we cloned 130 Linux guests at 1 gig of memory each. Took less than 20 minutes. We got our ZVM paging rate up to 24,000. To anybody who's a ZOS user, they would say that's absurd. In the ZVM space, not a problem at all. As long as you have an IO subsystem and a paging configuration that's capable of it, ZVM will page thousands and thousands of pages a second with no significant impact. The only reason we didn't clone any more servers is we ran out of our allocated disk resources. So I mentioned a few charts ago that we created a pool of disk for zPro to use. That's all the servers we could put in that pool size that we created. So had we created a larger pool of disk, we probably could have created more clones without a significant additional amount of time. We also, in that cloning process, cloned a number of CMS users just to prove it could be done. We did not clone any ZOS or ZVSC servers. That's a little more challenging. Those who have installed those two operating systems know there's more to it than just creating a copy. So at that point, our cloud POC is complete. That was 2 days of work in our data center. Then we had to go through and bring all of our workload from our old data center. So here's some background on that. One of the things we had to do was decide how to migrate. There's lots of ways to migrate your disk. I suppose you could physically ship the disk hardware. We actually considered that at one point, but we were a little worried about how long it would take to get it packed and move it from the old site to the new site, unpack it, reinstall it. That would be an entire outage. So we didn't think that was a very good idea. We considered the option of offloading some of the disk to some kind of a portable media and then shipping the portable media and then reloading it onto that DS8900. Once again, that would have avoided outages potentially, but it's awfully risky to ship that kind of data and you know, the possibility of losing some of the portable media or restoring it improperly. There just was too much involved in that. The best solution, if you have unlimited resources, is set up hardware replication. So we could have set up replication between our old DS8800 and our new DS8900 and let the networking trickle that over and then break the replication and cut over. That's the most reliable and the least amount of outage. The only downside to that is it has fairly significant cost to it. You have to install enough network bandwidth, put in the dedicated hardware to do that frame-to-frame replication. We just didn't think that it was necessary to do that for our particular migration. If you have production workload with customer information on it, high demand for transactions, that kind of thing, that's the only way you're going to be able to do it. For our case, as a software development company, that was not necessary. So what we chose was to use standard VM software along with a contributed utility that is available to anyone. And we just migrated it using VM tools from one location to the other over those internet connections from the old data center into the new one. The tools we chose were Pipe DDR, which is DDR is a disk dump and restore that comes with VM. Pipe DDR wraps that basic functionality in the CMS Pipelines facility, which is a high performance, fairly significantly low overhead tool. And we implemented the zlib compression in that. You'll want to do that. That gives you the best opportunity for compressing the data and managing the throughput. You will want to double check which compression works best for your data. We chose to use the default. I think there are 9 compression options, if I remember correctly, and we just let it default, and I believe that's number 5. So the average migration over our network pipeline was a 3390 Model 9 or a 4 GB LUN in about 7 to 10 minutes. And that is dependent a lot on how dense your data is. The more space, the faster it goes. The more full all that space is, takes on the longer end. We had about 3.6 terabytes to copy. So what did we do first? We shut down one of the systems in the old site. We copied the DASD for that one system using one of the other systems in the old site and one of the new cloud systems in the new site. So we migrated that DASD from the old 8800 to the new 8900. and we IPL'd that system in the new site. Then we could use that machine, that LPAR, to migrate all the rest. And that's basically what we did. We did all of the systems and the FCP Luns in various stages. We migrated all the DASD for our servers, tools, applications, etc., that could be taken down. We could do that in parallel to our normal production workload. So we have a number of test systems. We have data that we use for our testing, any number of things. I think we migrated about 2 to 2.5 terabytes of DASD that way, that were not critical to our day-to-day operation. Then we shut down the remaining 4 systems at the old site. We migrated their DASD, IPL'd them then in the new site. And then the last phase of the migration was to take all of the LUNs on the FCP side of our storage subsystem and migrate those. And we also did that migration using the same pipe DDR tool, and by defining those LUNs as VM EDEVs. And if you're not familiar with an EDEV lets you take any size LUN on your storage subsystem and define it and make it look like a pseudo DASD volume on VM. Once it becomes a logical DASD volume, then pipe DDR treats it just like any other DASD volume. We migrated everything from a whole bunch of 4 gigabyte LUNs up to a 100 gigabyte LUN that we had created for doing unloads and reloads and backups at the original site. So that was quite an experience. In order to validate the migration, we moved the disk related to any given workload, and that allowed us then to test it. We did it, I mentioned before, we did the test systems first, test data archives, non-business critical workload. The first ZVM system we did during normal work hours, which is what I talked about a minute ago. The disk copy for that system was just about 2 hours. The remaining 4 systems we migrated overnight. We did it in 2 phases. We did our development and customer support standalone systems one at a time. So in other words, back to back. We didn't do them in parallel. We took down one system, migrated it, took down the second system, migrated it, and brought them back up. That was an under 12-hour migration, did that overnight, one night. Then our remaining 2-member test SSI, we started that same night and we finished it the following afternoon, about 16 hours worth. So there was more of an outage to that, but that workload is all our test workload, so it was not customer impacting. Once again, you have to know what your customer requirements are, what your production workload requirements are, to know whether you can afford to have those kinds of outages. So in effect, it was shut down the systems of the old site, copy the DASD, IPL the systems of the new site. And I talked a little bit about this. Here's a little more detail on the FCP Lun migration. Basically, there were LUNs in the old data center on both an old DS6800 and a DS8880. Those on the 6800 just had never been migrated. I think there were 12 remaining LUNs on that 6800 subsystem that had to be migrated. And so rather than migrate them from the 6800 to the 8880 and then a second migration, we just migrated them directly from the 6800 to the 8900 in the new site. So it's a simple number of steps. Do a CP set EDEV in both the old site and the new site. And then use the pipe DDR function to copy from the old site to the new site, and then delete the EDEV definitions. Once that's done, it's just a LUN on the storage subsystem, just like any other LUN, and then you could attach it to Linux or do whatever its original intent was, then you could do it in the new site. So I've probably gotten this done a lot faster than I needed to. That's about what I thought, about 35 minutes. The Z15 is really fast. So we came from a ZBC12. both single frame systems. The BC12, of course, was the older form factor, so the new one takes up a lot less space. It's a lot faster. 3 generations of Z, I think in raw processor, is more than 100% faster. Each generation has generally given you a 20 to 30% increase in speed. So if you factor all of those, we got a lot faster machine now. It's feature rich. I wish we had need for all of the features that are on the Z15. One of them that we were really excited about was the on-chip data compression. That one was really important for us as we have picked up doing ZOS monitoring. ZOS does all its data in SMF, well, SMF or RMF, but in order to do the monitoring that we needed, we were shipping a lot of data from ZOS to ZVM. By implementing the on-chip compression, we achieved nearly 90% reduction in the amount of data we had to transmit. That's impressive, and that's all built on the chip. Took some coding, obviously, to enable that, but that doesn't happen automatically. System recovery boost was another one of the features we took advantage of. Because IFLs run at full speed anyway, it's difficult to measure that it gets enabled and does much of anything. The only place we could see it a little bit was on the test SSI. We have a mixed mode LPAR, and when you do a ZVM mode LPAR has CPs and IFLs and potentially zips if you have them. When you do that, the master processor is always a CP. And if the CPs are running slowed down, Recovery Boost helps a lot in the recovery of that system. Other things we don't have, Crypto Express 7 is supposed to be incredibly fast compared to Crypto Express 6 even on the previous generation of machines. We do not have any crypto co-processors, so I couldn't measure those. And there are other new features. There's the Rocky cards and a number of other things that we just don't have a need for. A single system in a single data center, we couldn't take advantage of any more of those. The DS8910, that happens to be an all solid state subsystem, so we don't even have any spinning disk anymore, which is interesting. It's very compact. I showed you the picture early on. It takes up physically less than half of the rack space, so we were able to actually mount the HMC right in the rack. At our capacity, we have 36 terabytes of storage. That's the smallest capacity you could have. You can double the number of disk enclosures and at least double the amount of the density of the drives themselves. So we could have at least 4 times the amount of space or capacity, I mean, in the same space, which would be impressive. I've been around since lot smaller disk subsystems, and looking at all that happening. The other thing on the 8910 is, of course, the DS8000 series has great features. The flash copy, I mentioned we cloned in 20 minutes. You don't clone in 20 minutes if without the hardware feature of flash copy. If you're doing it with a software, it's going to take quite a bit longer, but with that fast a disk subsystem, even that runs faster. Global mirror, if you have multiple sites and have the need for mirroring your data among sites, there are a number of features like global mirror that are available on that DS8000. The last thing I'd like to touch on really is the early ship program. If you've never had a chance to do an early ship program with IBM, I strongly recommend it. Through the years, my 40-year history with mainframes, I have done a number of software and hardware ESPs. The ability to talk to the people who are making it happen is one of the best things I've ever experienced. In this case, we were able to get access to this brand new hardware, migrating from the BC12, I'm sorry, to the Z15 was it helped us to eliminate one step. So we went 3 generations of machine. If you get the chance to do an ESP, then you get to see the new machines hands-on. Of course, the fun of doing our machine in our data center was seeing inside, you know, opening the drawer and looking at the components. If you've had a chance to see the plexiglass version that IBM hauls to a lot of the trade shows, that's fun to look at, but it's even more fun to see how it actually works, or, you know, with all the real components running in it. That's enough on that. So in summary, we did this bare metal to cloud proof of concept. The brand new Z hardware, ZVM install is very efficient and very well documented. It's pretty much script driven. You have to do very little other than answer some questions. ZVPS and Z Pro both are easy to install under a couple hours, maybe at the same time, but at least a couple hours a piece. The documentation is well done. The steps in order to install those, it's mostly automated as well. Z Pro is really the key to this whole cloud system. It gives you the ability to do highly customized and fast server provisioning and management. So of course, if you're doing Z Pro, you can define, start up, shut down any virtual servers, and you can migrate them around your single system image. Incredible piece of software and very low overhead for both. Migrating between the 2 data centers, the great thing that we were able to do there was to migrate all of the workload using standard tools, what's built into ZVM and a few utilities, and we had no extended outages. So if you look at that migration, in less than a week, we built this brand new proof of concept and migrated all of our workload. So it was a great experience. Well, that is the end of my prepared remarks. I'd be happy to answer questions if there are any, or we'll move on. I'll return it to Dave.
Thank you, Rick. Rick, I wonder if you could put the last page with the QR code on there. Please remember to provide feedback. This information is very important to us for future planning and knowing what sessions were good, okay, whatever. So just a moment, I got somebody just coming into the. Hello, Mark. So yeah, if you could provide feedback, that would be great. Are there any further questions? I think we're getting some very late comers. We've I'm not sure what's going on here. The presentation is finished. Oh, there's three come in now.
Maybe time change.
Yeah, I have to say I'm a massive fan of Z Pro because, as you know, we've been using it to clone ZOS systems, primarily for trading purposes, to provide timed project availability of ZOS, so we can actually create a ZOS guest for a particular project for 3 months, and we find that very, very useful.
Well, as you mentioned, testing on top of ZVM is probably the biggest benefit I've seen of over the years. I remember when we first did our second. I'm going
to have to cut you off, Rick, because I think
no problem.
The keynote's starting now, so that's going to be starting in 10 minutes. So I think maybe I better get off.
Thank you for attending.
Yeah, thanks, Rick. Thank you, everybody.